ultimately these are formulas or properties that come up because of how you calculate the scalar product. So the following formula will calculate the angle between two vectors. So if you have vector u dot vector v, meaning the scalar dot product, that's equal to the absolute value of the length of u. So if you remember back a couple of lessons when we found the length of a vector, you're basically applying Pythagoras. And then times the length of v times cos theta. So the theta is the angle between vectors u and v when joined tail to tail. So that would be if you have two vectors going in this direction. So this is u and this is v. They're joined tail to tail. So what you would be calculating is that angle between them. Okay, and then the absolute value of u is the magnitude of vector v. And that again is when we apply Pythagoras. And once we do some examples, it should refresh your memory. And then the absolute value of v is the magnitude of vector v. We can calculate the angle between two vectors by rearranging the formula. So this formula right here can be rearranged so that you isolate cos theta. So cos theta is going to be the scalar dot product divided by the length of u times the length of v. Now, some other properties that come up, if you have two vectors that are ultimately the same or going in the same direction, two vectors can be said to be coincident when they point in the same direction regardless of their magnitudes. In other words, they lie upon one another. So if you have a vector going in this direction and then another vector going in that direction, those are coincident vectors. And you learn about that in, is it 20 or 30? I can't remember when you do systems of equations, 20 SP or 30 SP. When you're doing systems of equations, you have dependent, independent, and what's the other one? Inconsistent. Dependent or when they're the same. Another way of saying dependent is coincident, and that's when they're on the same line. Now, basically, when you look at this, this means that they're parallel. Now, if lines are parallel, or I guess I should refer to them as vectors. If you have two vectors that are parallel, what's the angle between them going to be? 0, right? So if you look at this angle, or sorry, this vector and this vector, there is no angle between them because they lie on top of one another. So your angle theta is going to equal 0. So now if we plug that in to the formula, cos of 0 equals u times v over u v. Then what does cos of 0 equal? 1. So then if we cross multiply, you're going to get u v equals u dot u. So or sorry, that should be v. But here, when we talk about them being the same, you're going to the scalar dot product is going to be equal to u squared. To be honest, this one isn't going to come up very much. You don't really, it's not one that you'd need to memorize because if you plug in, you're going to find that anyway. Well, I probably should have just done u times u here, but I mean, because they're saying that they're the same thing. So ultimately, if they're the same thing, they're just one on top of the other. And to be honest with you, this one to me is not that important of a property because it's not a situation that comes up very often. The only thing I guess you could get asked on the exam is if they say, you know, two vectors are coincident, you need to know that they lie on top of one another, and then this is the property. Now, if u and v are perpendicular or orthogonal, and orthogonal is just another term for perpendicular, and again, we need to mention it in case in a question it comes up so that you know what orthogonal means. And that term is only going to come up in vectors. Then u times v is equal to 0. Now, if vectors are perpendicular, so if we have a vector going this way and a perpendicular vector, what's the angle between them? 90 degrees. So if we plug that in, we would have cos 90 is equal to u dot v over the absolute value of u times the absolute value of v. Now what does the cos of 90 degrees equal? 0. So if we cross multiply, you're going to get 0 equals u dot v. So what they're saying here is the dot product will equal 0 when the vectors are perpendicular. Okay, so the last one, when the two vectors v and w are parallel, v times w equals the absolute value of v times the absolute value of w. So I think what I did up here was I more showed this one here, because I should have kept them the same. If they're coincident, they lie right on top of each other, so they're the same. So like if we just go back here, I probably should have just used u. That's what they're showing there. Down below, this next one is where we want to go. Again, they're parallel. So parallel lines, the angle between is going to be 0. So we're going to have cos 0 equals v dot w over v times w. And again, the cos of 0 is 1. So then we basically prove